It is one of the two main forms of energy, along with the potential energy, which is the stored energy contained within objects at rest. Understanding kinetic energy is intuitively easier than understanding potential energy because it's more obvious that moving things have energy. The total kinetic energy of an object depends on several factors, such as the amount of work done on an object and its acceleration after a moment of inertia from external forces. The most important factors that determine kinetic energy are the motion measured as velocity and the mass of the object in question. So, an object that is moving is, we can call it as a kinetic energy. So, yan na siya. What are the characteristics of kinetic energy? So, the main characteristics of kinetic energy are movement and moving objects. Kinetic energy is never present in an object at rest. So, dili present ang kinetic energy sa mga object nga dili ga-move. So, there are countless examples of kinetic energy at work in the real world. So, example for that is the roller coaster rides, cars driving downhill, skydiving, hitting a golf balls, and anything actively moving is an example of kinetic energy. So, what is kinetic energy measured in? It is measured in the same unit as all types of energy. Joules gihapon siya. So, dili na lang nako siya basahan. So, are there different forms of kinetic energy? So, yes, there is different types. So, one of this is the rotational kinetic energy. So, rotational kinetic energy is created by moving objects around an axis. These types of energy depends on how fast the object is spinning, how much it weighs, and where the center of mass is located in relation to the axis. So, some example with where rotational kinetic energy is important include flywheels, molecules for thermal kinetic energy, turbines, and the Earth, which rotates on its axis as well as around the sun. So next is the translational kinetic energy. So this energy is caused by objects colliding with one another. The key component of this type of energy is that all molecules of an object travel in the same direction under the same force when it's applied. So an example ani is striking a golf ball and okay mo to siya. Vibration. The next is, last na ni siya, nga types of kinetic energy is the vibrational kinetic energy. So, vibrational kinetic energy is unsurprisingly caused by objects vibrating. It's essentially the energy of an object due to its vibrational motion. A vibrating smartphone and the sound coming from a drum solo are two examples of vibrational kinetic energy. So, si Charlene is bearing a part.
Good afternoon, everyone. So, kani amo sample sa kinetic energy. A car is traveling at a velocity of 10 meter per second and it has a mass of 250 kilogram. Compute its kinetic energy. Answer, ang given kay, ang mass is 250, ang velocity is 10 meter per second. So, pagkuha nimo sa iyang kinetic energy is, ang iyang formula ni is, kinetic energy is equal to 1/2 times mass times velocity squared. So, ang answer dayon is 12,500 joules man taning nadan. Manaplan dyan. Next slide dyan. A car is moving down the road with a speed of 20 meter per second. If the mass of the car is 600 kilogram, how much kinetic energy does the car have? So, ang given is velocity 20 meter per second. Ang iyang mass din is 600 kilogram. So, ang solution is kinetic energy is equal to 1/2 times mass times velocity squared. So, ang one name is kinetic energy times 0.5 times 600 kilograms times 20 meter per second squared. Ang iyang answer is 1, 120,000 joules. So, if i-double nimo ang iyang speed, mag-quadruple ang energy sa mag-quadruple ang energy. So, if ang kaning buhaton nimo og 40 meter per second ang iyang dagan, moabot dayon ang iyang kinetic energy og 480,000. So, kay bali mo rag kaupaton niya ang kuan energy sa isa ka butang. Next slide dyan. A girl is riding a bike with a speed of 5 meter per second. If the kinetic energy is 550 joules, what is the combined mass of the girl and her bike? So, diri nga problem kay ang gapangitaon ang kabugaton sa object ay atong sa kabugaton sa bike ug sa babae. So, ang iyang formula is kinetic energy is equal to 1/2 times mass times velocity. Tapos, imo na yung buhat na nani kay i-times nimo siya sa 2. Ang kaning 1/2, walaon na siya, kulihan og 2. So, ang mahitabo is 2 kinetic energy is equal to mass times velocity squared. So, ang mahitabo is mass is equal to 2 kinetic energy times divided by sa iyang velocity. So, ang given is, ang mass is, ang iyang speed is 5 meter per second, ang kinetic energy is 550 joules. So, ang mahitabo, mass is equal to 2 kinetic energy divided by velocity. So, 2, 550 joules times 2, i-divide nimo siya sa 5 meter per second nga velocity, i, i ay nako. Square ang square root aning what ay square root 5 squared day. So ang answer is 1,100. I-divide nimo siya sa 25. Ang mass sa girl og sa bike is 44 kilogram day. So, next slide yan. So diri nga problem kay ang gapangitaon is ang speed. Billy drops a rock with a mass of 0.45 kg from a cliff of into the lake below. If the kinetic energy of the rock just before it hits the water is 140 joules, what is the speed of the rock? So kung ang mass ang gapangitaon, divide nimo siya sa kung ang speed ang gapangitaon, gamitan nimo siya square root. So kibali ang mahitabo is i-square root nimo siya. So B is equal to 2 kinetic energy divided by B is equal to square root of 2 kinetic energy divided by mass. So, naman, makita man ang iyang wonder. So, ang wita mo is velocity is equal to square root of 2 square root of 140 joules times 2 divided by 0.45 kg. So, ang speed sa rock before siya natagak sa lake is 25 meter per second. Wala to, sir.
Bea.
Charlene.
Ito si Betsy.
Sige, continue. Kinsa yung third member? Gemma?
Si Betsy Rose, sir, yung tuning part.
Asa siya karon? Sige, i-continue na lang. Gemma?
Okay.
Sige.
Okay, sir, basahin na lang ako. What are the main rules for kinetic energy? If there are any main points to take away from what kinetic energy is, it would be that it's the energy of motion and it requires force to act upon the object to get them in motion. It's also important to take note of the three main subtypes of kinetic energy: rotational, translational, and vibrational. And don't forget Newton's second law, which states that potential energy in any exchange will always be less than that of the initial state. Sorry for that. With those basics, you will be able to understand the main rules associated with kinetic energy and have a better feel for the force at work next time you drive downhill, ride a roller coaster, or hit a beautiful tee shot in game of golf. Okay na.
Okay, class, you have questions? Uh, Kinetic energy. So your examples are just translational, no? Objects that are moving in a straight line. Gemma?
Yes,
Yes.
sir.
So questions from the class. Now, in order for you to understand what is kinetic energy, you can try the PET simulation. I'm kato bitang what's this one? Roller coaster simulation sa PET. You can try that one para ma-simulate ninyo kanus maximum ang kinetic energy kanus sa pud siya minimum. Did you try that simulation, group 9?
Wala,
Gemma?
sir. Wala, sir. Nabo na try. Sorry.
Okay. So, I'm supposed to share to you but hinay kayong internet, no? I cannot open the website. Nambot nga ano ni. Anyway, kamo na lang class, no? Pwede naman na kamo na lang mag-explore sa PET simulation. Daghan man na siya dito. Okay. So, Gemma, how are you
Yes, sir.
going to give your quiz?
Ang saan na to siya?
Kung sa inyong gusto ipabuhat sa inyong classmates, sa inyong quiz?
Kanang ano na lang siguro, sir. Ay, more wa pa man pud jud mi naka-decide sir on saan na mo. Pero mag-solving na lang pud mi. Butahan na naman siya solving.
So, siguro you have solving and then you have multiple choice, no? Para balance, no?
Okay, sir.
Okay.
Yes, sir.
And do not forget, you add me as collaborator so that I could receive the editor's link. And then you make it early. Nana mo nahimo nga quiz? Wala pa.
Nanagamay pa, sir.
So, isend lang sa ako ang link para ma-check na ako inyong items, no? Okay ra, group
Okay,
na yun.
sir. Okay, sir.
Yes, sir.
And absent for this afternoon is Gusto absent sa inyo karon?
Si Betsy Rose, sir.
Betsy Rose, wala siya.
Naman to siya ganiya, pero amot nga na nawala siya.
Okay, Godwin, do you have any question about the topic? Nasabtan ninyo giun sa tong sample problems pag-solve. Yun sa pag-solve ang mass, ang speed, and then ang kinetic energy.
Yes, sir.
Or do you have something to add?
No, wala na, sir.
Wala na. How about you, Gia?
Wala na, sir.
Okay. So take note the unit of joule, the unit of energy. So, okay. So group 9, congratulations now for being able to deliver your topic this afternoon.
Thank you, sir.
Let's have group 10 for another topic. Group 10.
Agraviador.
Kadyot lang, gi-prepare pa na ako. Di ako.
Hey, what happened? By the way, class, now this is the link that you're going to explore. Energy Skate Park, no? Okay, so you can do it later. Nikki,
Yes, sir.
masugod na sila, Nick.
Wala. B? So, good afternoon, sir. Good afternoon, classmates. Our topic is work energy theorem. Takak mga group. Sir, ki Karkwe, bili siya kasulod kay tayo.
Paki-maximize ko sa screen, Ivy. Class, by the way, insay reporter sa potential energy.
Kami, sir, group 1.
Okay, sige. So after this, balik ta sa 1, no? Kay group 10 naman mo kutob, no?
Pero karon na mi after mag-report, sir.
Next ano na lang. Next Monday na lang, no? Okay. Cycle man ta.
Okay,
So
sir.
this is the last topic for the first batch, no? Or first cycle. So sa second cycle of reporting, balik na punta sa group 1 and then their topic will be potential energy, no? Take note lang, class. Sige. So ready na? Class, kasi kao ba ni Ivy? Group 10?
Si Karen, sir, kay dili daw nakasulod kay Munay ang net. Tapos si Jason kay wala.
Nikki, please take note ha, sa tong mga group members nga wala, no? Take note lang
Yes,
po.
sir.
Okay. Ivy, okay ra ka? Ikaw rin mag-report karon. Nikki, Do you have a problem
Yes,
with oh, Ivy? Do you have a problem with presenting the screen? Pwede ka magpatabang ni Nikki.
oh, sure, sir. Wait
Oh,
lang.
so I think everyone can see the slides na, no? Klaro ba ang slides?
Our top work energy theorem. So, na-identify naman kagaila ang work. So, ako lang i-recap. So, work is energy transferred by a force which cause the displacement of an object. Energy, the capacity to do work. Next slide ni. So, energy theorem, when work is done on an object, there will be a change in that object kinetic energy. Where kinetic energy is the energy motion. So, kung mag-move ang isa ka objects, nasa kinetic energy. Next. So, work energy nila. Work equals change kinetic energy. Work net equals final minus kinetic energy initial. Tas EEA equals 1 half velocity squared. Tas ang formula sa work equals force times distance. Work the net work, the total done by all the force combined done on an object is equal to the change in the kinetic energy of the object. After the net force is removed, no, the object energy is the the following equation. Work kinetic change in kinetic energy equals final minus net result 20 kg cart at rest for a displacement of 150 meter across a fraction. So, and by force. So, work equals force. Muna ang pag-asa work times 12. So, work equals 7,500 joules. Is the final kinetic energy. So, kuha naman na to done work as change in kinetic energy mas kinetic energy initial. So, wala may kangkuan, wala man siya kinetic energy final. Next. For result is kanang isa Next, mass velocity square minus mass may initial ng R work is what mass final. So, at wide so ang coefficient equals 10 na so i-share siya kakuha ng velocity 30 and 5 I mean per second ang kanang half the car moving. Next. So how much is required to 20 kilograms car from 20 meter per second to meter per second. So work net equals half mass velocity in initial. So one half of it fast and one half next. So another example is one I what 165 accelerate to 20 per second is 2 seconds. Its acceleration. B velocity minus B1 tapos kan siya kan time 27 divide 2 so is so one half at square plus velocity 0 plus so one half times 10 times 2.7 squared plus 0.2.7 equals 36.45 meter. How much work was done on car? So one half meter times velocity squared minus velocity initial squared. So ang isa ka velocity final o velocity squared initial. So one half times 1,650 times 27 squared minus 0. So ang kwan siya is 50,100 601,425 joules. What is the average force acting on the car over this time interval? Use your formula force times distance and solve for F to find the average force acting on the car. So force equals work divide distance. So 601,425 divided 36.45 equals 16,500 Newton. So another, ano pa dyan siya example? Gram located from 2.0 meters per second to 4.0 meter per second as it is pulled across a table. What is the amount of work needed to accelerate the book to the nearest 10th joule? So work net equals change in kinetic energy. First, we will need to use the kinetic energy equation to figure out the change in net is change in kinetic energy equals kinetic energy final minus kinetic energy initial, then solve for kinetic energy using the equation for kinetic energy to find E final, key initial. So key equals 1/2 mass velocity squared. Key equals 1/2 times 2.0 kilogram times 4.0 meter per second equals 16 joules. Tapos, ang kinetic initial is 1/2 times 2.0 kilogram times 2.0 meter per second equals 4 joules. So, ang now solve for change in kinetic energy is 6 minus 4 equals 12 joule. Ito na siya ang work net.
Okay, IB, do you have another example? Okay, so for this version of the work kinetic energy, this theorem establishes the direct relationship between work done and the change in kinetic energy of a moving object. So muna yung pasabot, no? Kindly go back to the first equation, IB. Nikki, ikaw man Nikki ang nag-ano ba? Nag-operate. Okay, so why do you need to determine first the work done? So remember, the work done by an applied force, so for example, imong gitulod ng object, you are performing work that is that could be computed as force, applied force times the displacement of the object. So remember, this was our topic last week. So for this example, you have 15 newtons of force applied horizontally to a 20 kilogram cart at rest. So the work done now is 7,500 joules. You can always review the computations if you have time. Gia, tama ba ning answer?
Yes, sir.
Okay ha, paki-verify na lang. Okay, so in the problem, according to the problem, ang object nimo is initially at rest. So mag yung at rest, it is already understood that your initial kinetic energy is
0.
0. So ayan ang makatingala nganong pag-compute ni dayon sa final kinetic energy, you are sure na it's equal to the net work done is equal to final kinetic energy minus the initial kinetic energy. And since the kinetic energy initial is 0, ay at rest man siya, so you are safe to say that the final kinetic energy must be equal to the work done. So that's why final kinetic energy is also 7,500 joules. Question. Klaro to siya, no? So, kung kabalo mo sa work kinetic energy theorem, you can always predict the other variable. Kabalo lang ka sa initial and final value sa imo kinetic energy. No? That is why we call it delta KE. So it's the delta that matters. Delta is the change, no? From final value minus the initial value. Questions? Naka in your class? Okay. So this is just one form of the theorem. Napaisa ka form ang theorem. The other form is in terms of the potential kinetic, potential energy. Kini sa kinetic energy ni siya. The other version is in terms of potential energy. So I guess Ivy was not able to discuss that here. Puro naman ni kinetic energy ang iyahang example. Okay, class? Klaro ba?
Yes, sir.
So, do you have any other question? So, Ivy, can you include katong isa ka form of the theorem? Idugang na lang, Ivy, no?
Yes, sir.
Dati siya sumpay, katong ni siyang work is equal to the negative of the change in potential energy. O, baliktad to siya kay negative man. No? So, kibali, para masabtan, no? Can you go back to katong previous ani? Katabi itong, kini. Ito na siya. How much work is required to accelerate a 20 kilogram cart from 20 meters per second to 50 meters per second? So, unsa inyong pagsabot aning from 20 to 50? Nag-increase ang kinetic energy or nag-decrease?
Increase.
Nag-increase siya, no? Obviously, because your object becomes faster. Diba? Ang kinetic energy is directly related to your speed or velocity. Okay, i-square pa ba nimo, no? So, the more fast ang imong object, the more na higher siya ang kinetic energy. So, dini obvious kayo nga ang imong change in kinetic energy must be positive. No. So, maski dili pa nato computon, tinagsa, itinagsa man nimo ni pila ang kinetic energy for 20 meters per second and then pila ang kinetic energy for 50 meters per second. So, klaro kayo nga increasing ang imuhang kinetic energy. Okay. So that's it. So makita ninyo sa computation. Otherwise, kung mabaliktad ninyo sa formula, you would get negative value of work. So, inyo tayong hunaon kung kinahanglan ba negative ang value sa work kung increasing ang kinetic energy? It's impossible. Dili pwede. So, dapat kung positive ang value sa imong work, it means also that there is also an increase in your kinetic energy. Question so far? Warren, na kay question diha? Clarification? Okay, so Nikki, okay na Nikki. So I'm going to share to you the katong kinetic energy. Okay. Okay, class, can you see my screen?
Yes, sir.
Klaro ba? Okay. So this is what I am telling you about itong energy skate park. You can make use of this to simulate your kinetic energy, potential energy, as well as apila din ang work energy theorem. So, for example, no, ini nga person nakatungtong sa skate park, pwede na yung mabutangan o grid so that you can see the height, the altitude. Okay. Ayan ka na siya, no? So, you can set the speed and the path taken. Ako na sa ibutan din sa pinakataas. So what do you expect? When I release the person, the skate, asa sa kutob? Tama na ba sa bottom? Or mula ho sa pikas end sa tawag na? Ining curvature bitaw? Gia.
Magkano siya, mabalik ra siya pa-down dayon if makaadto na siya sa top sa other side.
Okay, top sa other side, no? Sige na. Okay. Release na to, no? Okay. So kung asa sa gikan nga level, most likely balik sa dito nga level. It's because ang imuhang kinetic energy is na-conserve siya, no? Pero makabantay mo nga ang speed mag-vary, no? Na ay paspas kayang speed, na imuhinay po siya, no? Okay. So wala yung propose nga mo ni ilahang project energy skate
Naa, sir.
Sir.
isa nga grupo.
Group 3, sir.
Group 3. Sige, group 3, no? Na-try na ninyo ni?
Yes, sir.
Okay, very good. Sa group 3, palihog na lang ko og kaning facilitate aning activity kay inyo man di ay ni ilang na ako gusto nga ma-spoiler alert, no? Na man di ay mo in charge ani. Please facilitate on this one, no? Provide the activity sheets sa ubang grupo so that they can also try this one, no? Sige. And I will look into your results kung sa bagid ang inyong nasabtan adtong activity. But so far, nanarigyo tanan dito ang energy conservation topics, no? Potential, kinetic, napagani thermal, no? Sige. So, okay. IV, napakadiha.
Sir. Yes, sir.
Ato lang inyong idugang, no, katong potential energy pod nga component or version sa inyong theorem, because later on mo-arrive man gud sa conservation equation. So kini nga topic mura na siya og coin nga naay duha ka sides, no? Two-sided coin. Dili unimo sa matawag og coin kung wala siya kung dili back to back ang iyahang side, no? So dili kompleto atong concept kung puro lang kinetic then walay potential. Okay, IV na paki-add up lang ko adto idugang na sa inyong slides.
Sir.
And then may quiz IV?
None na, sir.
Unsa inyong plano? Multiple choice tanan or
Yes, sir. Multiple na. Pwede solving them.
Okay, sige. Sige class, no? Mo lang na akong ipatiwas sa inyo og buhat karon. for the entire week ang inyong VLA, it's time na gyud para mahuman ninyo, aya ninyo siya i-facilitate sa ubang grupo. So mag-set mo og time para ang ubang group ila pong i-test, ila pong i-perform. Nakuha inyong class?
Yes, sir.
So do you have questions on that one? Ang ano na lang man ang inyo, once na inyo siyang nasulayan na simulate na ninyo, so kabalo na mo sa unsay implications, unsay output, unsay pwede mahitabo. So aya din ninyo siya ipasulay po sa ubang grupo, ay ila pong i-test pod, no? Perform pod nila. The same procedure that you put on your procedures in your VLA, mga gihapon to siya. So make sure lang yung VLA readily available na sa drive para diretso na lang dahil download. Okay ra class?
Yes, sir.
Sige, so okay. Now, atong isa-isahon ang components in technical paper, no? Magsugod ta sa introduction. So, I hope you could start with your introduction. We just make use of the sample technical paper na akong gi-provide. Mo to siya ang format, writing style na inyong pwede ninyo i-adapt for your introduction. So, Christian J, nakasugod na mo sa inyong introduction. Christian J. How about you, Nikki? Nakasugod na mo, Nikki?
Wala pa, pero siguro after our time karon.
Okay ha, so ana lang akong ipahimo sa inyo, no, para taas-taas po yung time to write down your introduction. Sa inyong introduction, you put it there, you emphasize your unsay kulang na inyong nakita, no, unsay inyong gusto ninyong i-perform, i-prove, i-provide ninyo knowledge, no, regarding your simulation. So just check the sample, but do not copy the sample, ha, ang content. Ano lang, ang format lang. O kung masurpass pa ninyo, mas maayo, mas mapanindot pa ninyo ang pag-discuss sa inyong introduction, mas maayo, no? Okay? Analu, nakasugod na mo, Analu, sa introduction?
Wala pa, sir.
Okay, so Ivy, congratulations Ivy for your composure, no, nga magpadayon gihapon sa pag-report maski ikaw ra usa, no, ana lang, no. Ivy, ato lang inyong idugang. You can ask your group mates to help you, no, sa pag-revise sa inyong slides. Ivy, okay ra?
Sir. Yes, sir.
Okay, Nikki, after this one, no, paki-check sa attendance, i-post lang ang attendance dito sa tong group chat. No? And then kung doon na pa mo ilaing concern, kay kining groups 9 and 10, Ivy, Gemma Rose, maghatag pa mong quiz, no? Within this week, i-post lang ninyo.
Okay, sir.
Okay, so sige. So if you have concerns to class, post lang dito sa atong group chat, no? So that I could answer you once and for all. So, wala na lang sa. So again, no, congratulations to the reporters for the topic well delivered this afternoon. No? And then, if you have questions regarding your introduction, regarding your VLA, so post lang ninyo sa group chat. Uh, wala na may questions, class, before we dismiss early. Clint, nakipangutana, Clint.
Wala na, sir.
Okay. Okay, so see you next meeting, class, now. So stay safe and God bless. Goodbye, class.
Bye, sir.
Thank you, sir.
Thank you, sir.
Bye, sir.
Bye, sir.